Okay, hello everyone. We are starting a new module. We are continuing to work with multiplication. And to be better at multiplication, we need to find factors. So our lesson for the next 2 days will be focusing on finding the factors for numbers 1 through 36. Our I can statement is, I can list the factors of several numbers between 1 and 36. Eventually, you will be assigned numbers. And as you work on these numbers, you will make the arrays for them. I will let you know what that means as we continue our lesson. Okay, so we're going to start out with a little problem here. We've got a bunch of these little lights, and it says that Cindy's class is selling tea light candles for a fundraiser to help the local cat shelter. Oh, I just love this lesson. They're trying to help the kitties. I've got some thumbs down going on out there. Oh, we're going to have a feud over this. Okay, the tea lights will be packaged and sold in sets of 12. How many different rectangular boxes can you design that would hold 12 candles? Use the tiles to model your boxes and pretend that each tile will hold exactly one candle. What I mean is that we will have we're going to use our squares that represent our candles. I'll tell you when you can use them. And we're going to arrange them in boxes that can be sold. Think about it when you buy things in the store. You don't have odd-shaped boxes. Boxes are square or rectangular. What we cannot do is make layered boxes. So we can't have like 2 or 3 layers of candles. It's just going to be all one box so that when it's packaged, you can see them. So what are the different ways that you can show using these tiles, the different kinds of boxes you can make? Eventually at the tables, the students are going to work at this, and they are going to try to get as many different kinds of arrays at their tables as they can. So here we go. I'm going to pause our screen while we work. Okay, so the students have been very, very busy working on their arrays, their different shaped boxes. I challenged the class to show whatever shaped boxes they possibly can come up with. And I noticed that Anna, Luke, and Millie were the first ones finished to have all 3 different kinds of boxes. They just can't come up with any more. So I need you 3 to come on over and start arranging to show your boxes. Here they come. No, use mine. Use mine. It's just faster, and they're easier if they're smaller, because otherwise they just don't fit under the camera. So Millie's going to show the way she made hers. And I have the ruler, so if you need to use them to straighten it out, you can. Everybody else is going to patiently wait. No, it's not. You're supposed to. No. Okay, so Millie made a box that looks like this. Okay. Luke, can you show us yours? And the ruler works so nice to straighten them out. Okay, so that's what Luke did. And then Anna did another way. Thank you. Using the tile pieces the students have at their seats. is much more exciting than trying to maneuver these little bitty guys. But I don't have the space under the dock cam to have all of them. Okay, thank you, Anna. Oops, I'm going to move this a little bit. Okay, so Anna made her box look like this. Okay, now watch what happens. See how Anna's box is? Now it's different. Anna didn't make that box. Did anybody make a box like that? Will's got his hand in the air about this. Is this box different than the one that Anna made? Raise your hand. I'm looking for a discussion. Look what you think. I don't know. I haven't even touched them. And is this one any different than this one?
No.
Just watch my fingers. Are my fingers touching these?
No.
Now we have it that way. Now we have it that way. One way is showing us 2 times 6, 2 rows of 6. This way is showing us 6 rows of 2. Do they give us a different product? They do not. What I've been talking about is the commutative property of multiplication. When we talk about the commutative property, it shows us that our array, those of you not looking at the board, please look that way. It shows us that we can have the same array. We still, on the picture we still have 6 tiles in our array. And it's showing us 3 times 2 is the same as 2 times 3. We can look at all of the words on the back, but doesn't the picture just explain it so much faster? Okay. So as we were figuring this out, we see that we have a set of factors here. We have a 2 and a 6 multiplied together make 12. We also have the first one done, 4 rows of 3, or if I switch it around, I have 3 rows of 4. I've just done the commutative property again. I did not change the number of squares. I just changed the shape, the direction of the box. And then we had the last one done. I'm not going to do as nice a job as Luke did with it, but you'll get the idea. That we have a long skinny box with 12 rows with 1 in each row, or we have 1 row with 12 in it. Both of them mean 12 times 1. And this means I have found all of my factors. What we're working on, I've got to put this the right way. What we're working on today is creating the arrays that show the factors. And class, you're going to discover that as you start working through this, I will have some posters on the board, and you're going to start looking at them, and you're going to start using them, and you're suddenly going to start knowing your multiplication facts. So as I get myself ready here, the class is going to put all of their squares away in the bag, and Luke, my math people, are David and Akaya are going to go from table to table to pick up the bags and put them into our tile basket. Okay. Notice what I'm writing. Uh-oh, that's not right. That's supposed to be a 6. You're being recorded, people. Okay, so as we are going through this, I've just listed the factors we've talked about, the factor pairs. So when we think about factor pairs, with the factor pairs, it's talking about the two numbers multiplied together to create the product. We already were studying the word factor. And we know that when we have factors, it's the two numbers we multiply together to get the product. When we think of factor pairs, it's specifically putting two numbers together. And then we've been talking about this word called dimensions. The conversation we had in class earlier was talking about 2D versus 3D. When we look at this picture, we can see we are measuring 3 dimensions, length, width, and height. When we are talking 2D, we're measuring width and length. Sometimes people call this height. Just like when we're multiplying with factors, notice, please turn your noses towards the board. Notice that we have a width. Here we have a width of 2. We have a length of 8. Here is a length of 8. Do you see how the dimensions are another way to talk about our factors? Okay, everybody did a great job of finding these, so I'm going to go through and demonstrate what you're going to be doing next week. We found all of the factor pairs. So I need to draw them. Let's see, I'm going to start with 1, 2, 3, 4 times 1, 2, 3. And I have this one to draw. There's 4 on the bottom. There's 1 there. I just did 3 times 4 equals 12. I bet I can do this another way too. Let's do this one. 3 times 1, 2, 3, 4. Okay, I think I'm going to pause this for the people at home as I continue to draw, and then when we have our discussion, I'll bring you back. Okay, so we're going to record. We have started recording again, and this is what we did while you weren't with us. We finished drawing the rest of our boxes, and we can see if I turn it, this box turns into this one, and vice versa. They just keep, so this box is the same as this box. That's what we mean by the commutative property. You can turn the factors around and still have the same product. Next week, when we begin this, I'm going to demonstrate what to do if you have a product larger than 12, because this paper is only 12 inches or 12 squares long. And next week, you're going to be assigned partners. Well, actually, you're going to be doing table groups, table partners. You're going to work on finding the factors. Does anybody remember the numbers we're going to find the factors for? Oh my goodness, they can't remember. I guess I have to put the other thing up. What factors are we finding? 1 through 36. Next week will be a long lesson when we go through making these things. Okay, so everybody have a great weekend, and we will talk to you again next week. Okay.